Well, hello everyone. Welcome back to Adrian's Digital Basement 2 Super Mini Mail Call. Let's jump right into it. This package, even though it looks like it's an Amazon package, I don't think it is because it comes from, well, it looks like it was like a mail delivery service handling thing. I have a feeling this might have come internationally, maybe just in a reused box, and I can't tell who this came from. So let's open it up. Oh, actually, there was a little pouch on here with this extra document here. Looks like this comes from Lorenzo in Bristol, the UK. So hi to all my UK viewers. Inside the box, we have this. Wondering if we're gonna have more loose components. After last week's video, there was a whole bunch of stuff talking about organization and lots of people email me, and I appreciate everyone for your suggestions. Thank you very much for that. Looks like we have a note here. Oh, and it looks like we just have some Haribos here, actually. So that's that's pretty awesome. I'm not sure there's anything to do with electronics here. Hi, Adrian. I love your videos on retro computers, especially anything related to the C64, and I hope you're doing great as a full-time YouTuber. Thanks, Lorenzo. I definitely am. This is amazing. I live in Bristol, and during my last visit to the family in Italy, I checked the gummy sweets candies and spotted some Haribo I wasn't familiar with. Maybe you've never tried them either, so here's an assortment of gummy candies. Rainbow Pixels, was this made for you? One of the sentences in the blurb on the back reads, colors in high resolution. I mean, we may be talking about VGA here. Frizzy from the Italian frizzante is like English fizzy, but in English, these are sour candies. As far as I understand, there are no Haribo manufacturing plants in Italy. My guess is these all come from the plant in Austria. Dragolo is a mix which seems to be popular in France, possibly made in France as well, and Troppi Slices is from the UK. Haribo has a few sites in this country, so it may have been made locally. Frutella Animals is a classic gummy candy, and Frutella is the name of a soft, chewy candy for some reasons used here as a brand by Italian Dutch confectionery companies. Do they taste different to the Haribo to you? And Big Fruit is an old-fashioned jelly sweet, less rubbery, more crumbly. Despite sounding French, Dufour was originally found in Genoa in 1829. Now it's part of a group with other historic Italian brands, Ela and Novi. Enjoy, Lorenzo. Awesome. Thanks very much, Lorenzo, for all of that. We'll just take a quick look at this stuff and then I'll open another box. There are the Rainbow Pixels. All I can make out is it does say right here, it's a product of the EU. So it doesn't really tell us exactly where this was made unless it's somewhere else printed on this package. These candies, though, they remind me of the Picabella candies, I think it's called, from Haribo. Maybe these are, well, they appear to be coated in something, so it might be citric acids that makes them sort of more sour. Let's take a look at one of these. Oh yeah, I love these types of candies. Just, they definitely don't sell anything like this here, at least Haribo doesn't. And yes, I definitely have a little bit of a sour taste to them, but absolutely delicious. I assume this means here no artificial colors, but yet the colors are pretty vibrant and pretty awesome. All right, next up, the Troppi Slices here, and they're big. So I kind of like the bite-sized candies more personally, specifically because you're not eating like a giant piece of candy every time. It's obviously supposed to be a watermelon slice here. That's good though. I wouldn't say that's watermelon exactly, but you know, my brain knows it's supposed to be watermelon and I can taste the watermelon hints there. Looks like the flavors in these are pineapple, blood orange, and watermelon. Yum, really good. Not too sweet, kind of has a sour taste as well, which I like. Okay, here's another Italian one, the Dragolo ones. And as far as manufacturing location, the only thing I can see here is that, well, these are made, I mean, not necessarily made, but at least packaged by the Italian arm of Haribo in Milano. It's funny how all the ones they sell here always show where they're made, and you kind of get stuff made all over the place. UK, I've seen Turkey, I think I've seen US and some other places, and they absolutely do make like the formulations different. Even though they're made in Europe, a lot of them, they're still formulated for the US market. These gummies here with the white stuff, like kind of the milk stuff on there, I love these, and they're not super common here either. And we seem to have an assortment with these little round things, which obviously are licorice flavor. Actually, I don't know. That was a little black candy, maybe a little bit of licorice flavor, but it's actually more sweet than anything else and much better than I would have thought. And like there's some larger shaped ones in there. There's a green ball, and that's a pretty cool little assortment. I like those. Neat. And next up is this, which is the Italian candies here. Let's try these. I guess no artificial colors again. Oh, these are individually wrapped. Okay, let's try one of these here. Now, of course, with Haribos, even though we have like variants that are made by the, or, you know, sold by the Italian arm of Haribo, they're all relatively similar. But stuff like this is obviously like totally Italian and more specific and unique to the Italian market or Italian regions of Europe. And yep, this is more like one of the typical jelly candies, and let's try it. And that was very good. What's this similar to? It's hard to say even. If you have ever had Turkish Delight, which is kind of a jelly fruit flavored candy as well, but these are maybe a little chewier. I wouldn't call them crumbly at all. It's still like a jelly candy, but then it's coated with that sugar on the outside, and yum, really, really good. This is definitely the kind of thing, if I were visiting a country in the supermarket, I would pick up something like this, because this is very much not something you would necessarily see in the US, and it's definitely something that's pretty localized. All right, and then next up is Fruitella, obviously a Haribo competitor, and animals in English there, but it's got the white milk stuff on there. And let's see how these Fruitellas taste here. I'll go in for one of these red ones. Obviously no artificial colors, because it's not super bright. Here in the US, they're still using red number 5. Yep, I know, kind of ridiculous. And they don't use that stuff in Europe anymore, so the reds are a little more subdued. Let's give this a try. Although they don't taste anything like the Haribo equivalent of these, like the white and the gummy candies, they definitely have like a fruit flavor to them. Does it taste like super authentic? I don't even know what I just ate, if that was supposed to be strawberry or something. It didn't really taste like strawberry. It was just sort of a soury, fruity flavor, that berry type flavor. So couldn't really tell you. Definitely different than Haribo. Still good. Although I probably would prefer these types of candies in the Haribo ones. And as far as all of these so far that I've tasted, these pixels are freaking delicious. And then these ones, these two are top notch right here. Absolutely so good. But I think I have a soft spot in my heart for any kind of, well, these types of kind of square Haribos, and then the sour is just extra bonus. And then these are just awesome. They would kind of remind me of Italy. And the rest of these are good too. It's just that they're a bit more generic-y candy you can kind of get anywhere, but still very cool. So Lorenzo, thanks very much for sending in this little sample of candies from Europe. It's freaking awesome to get stuff like this from my viewers. And I think it was on the last mail call video that I had some candy as well. And I still have some of that left, but most of the candy from the last video, or is it 2 videos ago, that it's all gone, I think. And that's just because I get low blood sugar. I think I've talked about this before, right? Diabetes results in low blood sugar. Sometimes I need to eat candy or drink juice to bring it up. So having stuff like this on hand or in the car is perfect, because if I have low blood sugar, I just eat a few and then it brings my blood sugar up. So I know it seems counterintuitive that a diabetic would want to have candy around, but it's absolutely a necessity just because I'm manually controlling my blood sugar. Well, there's some automation with the closed loop thing that I use, but there's still times when my blood sugar goes low. And that's dangerous to be low, especially if I'm walking or driving. So I really have to make sure I have something on hand to always bring that up in case that happens. And although with my insulin pump and continuous glucose monitor that I have now, I get a warning if my blood sugar is dropping. So I know to eat some of the candy that I have on hand, often sent in by awesome viewers like Lorenzo and everyone else that sent stuff in. So thanks again for sending this in. Let's get to the next package. All right, next package is from Johann in Deutschland. So hi to all my German viewers. All right, what do we got here? I got a note, and we definitely have some snacks as well. I love it. So many snacks lately. These things have all been just hanging out in the basement here. To the black man, okay. And, oh, there's the Bella sticks. So I was just talking about the Picobellas, which I think are these chopped up into little pieces. Johan, you just watched the video and obviously noticed that I probably mentioned how much I love these, and you sent them in. That is freaking awesome. Okay, we have a handwritten note here. Let's see how good my handwriting recognition is. Boy, it's not often I get handwritten notes any longer. Johan writes, as discussed via Patreon chat, I'm enclosing a new SID replica, one piece for use with PWM output. Oh, okay, wait, we're talking about an ARM SID. Johan, I'm sorry, I think you sent this in, I think the box said it was from May, and I already had an ARM SID on the channel, right? Because I was given one as well at VCF Midwest, which was in September. So months later, this has been sitting here in the basement the whole time. Johan was probably watching going, hey, why haven't you opened the ARM SID? And I was showing a different one off on the channel. I'm also including two, is this like Batman style? I can't quite make this out. Something enjoying them. The reward is either for successful something. I'm sorry, Johan, I'm struggling to read your handwriting. I'm just not that good at it anymore. You know, back in the old days, of course, we read handwritten letters all the time, and my parents have pretty scratchy handwriting. I was used to reading it, but not so much anymore. As a discourse, if you decide something, I can't quite read it. Kind regards, Johan. Okay, well, let's see here what this stuff is here. All right, here's the reward. Oh, this is funny. This is funny. All right, let's open up all these little packages here. We got a whole assortment of stuff. There's one of the little DAC modules. These are the same ones the PicoGUS uses. Next up, this is one of the Chinese Raspberry Pi Pico RP2040 replica boards. I think the main difference on these is they have a bunch of PS flash memory and also an RGB LED right here. So something like 16 megabytes of it, I think. So we have a bunch of pin headers that go with that. And I'm sorry, I think in the letter I said something about ARM SID, but these are SIDKICKs. SIDKICKs are what I was talking about when I was talking about what I brought back from VCF. This is a SID replacement for the 64. It's all open source. This is what plugs into the motherboard, that is. Then you use the Raspberry Pi Pico, and there are two variants. One where it uses the GPIO pins from the RP2040 to create the sound waveform. It's pretty good sounding, but if you want the best possible sound, you pair it with the DAC module. Another version of this that has the DAC built in, I can't quite remember, but this DAC module then takes I2C out of the RP2040 and then does really high quality conversion over to the audio output. And if we grab the ZIF64, I have one of the SIDKICKs in here now. And there it is right here. Let's lift this out of here. So you can see the same SIDKICK board there. But I think the difference is the DAC is built onto this one now. Let's compare. Yes, okay. So the one in my left hand here, see it just says SIDKICK Pico version 0.1. Well, this is a 0.2 with the DAC. And you see the IC right there? That's the DAC that's integrated directly in. Oh, sorry, it's out of focus. That's the same IC. So this circuitry is now on here. And while there's no headphone jack, what it does is actually routes the output either to a header, where you would run it to the back, or maybe it's this one here, you run it to the back of your machine. Or you could set a jumper, which I have done somewhere on here. I forgot where. Anyways, that routes the audio right through to the SID socket itself. And the reason why I wrote sys 54301 is because you issue that command in BASIC on the 64, and then you end up inside a little program to configure this thing and also play some SID tunes. And I think you'd load some games and stuff in there as well. And in fact, what's cool is you could go on PCBWay, for instance, or I think probably others as well, and you can order one of these up and they will assemble it for you. So like you'll get these parts, the components soldered onto it, and maybe there's a version like this with the DAC, where this DAC stuff is also included directly on here, so you don't need to add these separate modules. I think even the pre-assembled ones do not have the Raspberry Pi Pico. This module you buy separately. Now the Pi Pico that's on here is one of the real ones, because you see it has a micro USB, and you can see this is one of the modern replica here that has USB-C. So it's a little bit easier to connect up if you just have USB-C cables lying around. But then this also has more of that flash memory built in as well, 16 megs, if I recall. And there are a whole bunch of these out there on AliExpress now, different versions that are pin compatible with this one. I think it's pin compatible with this one. I'm pretty sure it is. I think the biggest difference is it's a bit bigger. So if you have a layout on the PCB that doesn't allow for this larger board, that's where you can run into issues. There are also new replicas of this size board that also have USB-C on them, which I think I have right here. I think this is one of them because, yep, it is. So it's USB-C there. So even though this looks like a Raspberry Pi Pico, like a real one, it actually has USB-C. And the reason why I have that is because these adapters are really, plentiful, and I have a whole bunch of them. And of course, that allows me to plug in a USB joystick directly into this, so I can use that in DOS games and stuff. but I am not 100% sure this little board would fit in here just because of the component placement. And this one is actually soldered directly onto the board, even though I could have installed pin headers, but I didn't. And you'll notice it's the same exact DAC module that's on the original PicoGUS. Of course, the later PicoGUSs, which I know I've shown on the channel, Ian has integrated all of this stuff directly onto the board. So there's no longer a separate module here like there is on the original. That's the audio output coming through the DAC, and then this is for MIDI or MPU 401, which this thing can also do. Luckily, all the different versions of the PicoGUS are compatible with each other. It's just like the integration has been improved just for manufacturing ease and stuff like that, which I'm kind of assuming is maybe one day we'll get a SIDKICK that has all of this stuff, the RP2040 right on here, along with these other components. So it's really just like a little all-in-one board. But I think for ease of manufacture, they did it this way where you could just build them up yourself by, you know, stacking the components like this, and they all work absolutely the same. So I need to keep this stuff together. So this is one of them here with all these little pin headers that needs to be assembled. And then for the second one, this is the non-DAC version that of course does not have the little DAC module. And as I mentioned earlier, that's because the GPIO lines themselves are creating the audio output. So it's not as good quality, but it's just cheaper and easier because you don't have to buy this module, which is literally just a few dollars extra anyways. So a local friend of mine builds my kits for me. Hi, Sylvester, if you're watching. So I'm going to be bagging these up into their little bags here, well, new bags, and that way I will be giving them to you for construction. There we are. These are all bagged up and ready to be built up when Sylvester has time. I'm going to put this back in the C64, which I was like, where is it? Here it is, sitting right here. One of the things you have to be careful about is making sure you have the notch aligned. So the notch faces up on this version of the 64 and notch is sort of visible on the bottom there. Just make sure this is all aligned correctly here. And for optimal quality, of course, when using a DAC version, you wouldn't want to route the audio through the traces on the motherboard. It picks up audio noise and stuff like that. So you want to run some extra pins from the headers here over to your RF modulator replacement. And you see here I have, well, support for stereo SID, and this can emulate stereo SID, 2 SIDs. You have to run an extra address line to this, if I recall, and then I can run the stereo audio path directly to this board, which would be coming out of this little 3.5mm jack and bypassing all the noise on the motherboard. We'll take a quick look at that in just a second. And by the way, if you're wondering what this is coming out of where this VIC is, that is the LumaCode output from the last time I made a video about LumaCode. Let's just quickly test out my favorite Bella sticks here. Why on earth do they not sell these delicious things here in the United States? I mean, look at that. Yes. Creamy filling on the inside. Oh yeah, those are good. And look, sour flavor as well. So this is a German packaging here. And looks like the flavors we have are like a citrus flavor, a cola flavor, and orange flavor. And I remember reading that these are really popular in Spain. That kind of makes sense because look, Haribo España. This is from the Spanish arm of Haribo, even though the packaging specifically is for the German market, at least on this one. Okay, so let's get this thing hooked up. So we have an RCA cable for the LumaCode going to RGB to HDMI. Might as well plug into the 3.5mm audio jack here. And let's power up the machine here. What's going on here? That doesn't quite look right, does it? Oh yes, I think it does actually. LumaCode, now that I figured out my cabling problem on the RGB to HDMI, look at that pixel perfect amazingness that we have there. I mean, it's just amazing how good that looks. So let's run that sys command that is written on the SIDKICK. Oh, that didn't work. I think this happens sometimes. I remember this. You have to run it twice occasionally. There we go. Yeah, it took a second. All right, so it's emulating an 8580 right now, and this is where you can set up like multiples of them, and you have to say that the SID clock itself is running on an NTSC machine, which it is. Okay, so we hit F7 for files, and I did copy a couple things on here. So we'll just run the NTSC one, and there we go. So this is running, yeah, there's the sound. We've all heard it. I mean, who knew there would be a dance party here? Here we go, gotta do it. Nice, nice. Funny is the color palette showing on here is not, I don't know, it's not as vibrant as like a real NTSC machine here. Oh boy, this is all chopped off. So it doesn't allow you to select like which color palette you're using, which would be nice. That'd be a cool feature. That would be a firmware change for the RGB to HDMI. but I can just turn up the saturation, which I feel is like the biggest problem here. Although kind of that green that's viewable on the background there is like way too vibrant looking, and I don't know. Anyhow, if we switch over to the Kung Fu Flash here, turn the machine off first, of course. I'll pop this back on. Let's see what this looks like. Oh, that text is very vibrantly green. Second SID, no, it's not hooked up. And we can pick any of these 8580 SIDs here. Yeah, I mean, SIDKICK is awesome. And what's cool about it is obviously firmware changes to the SIDKICK will improve the emulation quality and whatnot. And because we're using the DAC version here, there are no issues with noise or whatever. And if you connect directly up to the SIDKICK using wires, especially if you use some shielded cables, you're talking incredibly good sound. The little DAC module that's included here, at least the one that's here, the little purple one that's used on the PicoGUS as well, it has such good sound quality for something that's just a few bucks. In fact, it's funny when the PicoGUS, I mean, if you've ever used an original Sound Blaster card, they have really noisy output. A lot of bus noise comes through the ISA bus, like through sound output and stuff. This card sounds so good compared to the original Sound Blaster or AdLib cards because of this little DAC module, which I think is 24-bit, 96 kilohertz or 192 kilohertz, 24-bit, something like that, capable. Anyways, I don't know what the I2C bus on the PicoGUS is talking to that DAC with. And I guess the thing we have to be concerned about, let's turn the audio down here. The thing you have to be concerned about is while the DAC module has really good sound output, obviously you got to give it some clean power. Now the SID itself, the SID socket itself gets clean power. That power is derived from a 7805 and a 7812 on the 64 motherboard. So this is like linear supplied power specifically for the VIC and for the SID. Anyways, if the design of the SIDKICK version 2 is not ideal when it comes to the DAC module, there could be some noise introduced there. But I kind of recall, even the way I have it hooked up here where it's running through the motherboard, it still sounds really, really good. The only thing that's different than a real SID chip, of course, is the emulation. And there are certain tracks and stuff that don't sound totally accurate. But on the other hand, these are very inexpensive. You can do stereo SIDs, you can do both kinds of SIDs, because ultimately, if you're listening to songs here, if we go back to my root directory here, see I have 6581 tracks as well. And that's because these were all designed for the original SID and they don't quite sound right. They work, they just don't sound exactly right with, the opposite SID. So with this, you have the best of both worlds. And using that little sys command, you can change it on the fly. You don't have to run some software to do it. There are so many things that are great about this project. I cannot speak highly enough about it, especially because, as I mentioned, this is a software-defined card or a product. All you do is hook up a USB cable to it, put new firmware on it, and boom, you have better emulation or other features. It's just completely wild. And my assumption is the version of the Raspberry Pi Pico here that has more flash RAM versus the one that's on here means that you could store more games and music files and stuff on there. And that means you can kind of get away with having an all-in-one 64 where you don't even need a Kung Fu Flash or anything plugged into it because you can load software directly off your freaking SID chip. I mean, freaking how cool is that? That is so cool. So that's really how the SIDKICK works. I highly recommend this particular product. And thank you very much, Johan, for sending in 2 of them for me. And as I said, my friend Sylvester will build these up for me, so I will be able to populate these into other 64s. And to be honest, for this 64, I'm gonna modify this RF modulator replacement board so it supports stereo, because I've actually never listened to stereo SIDs. Well, I've done it on an Ultimate 64, and I also did it on, of course, emulation, stuff like that, but not on hardware like this. So I should, I have the constituent things here required to make it work. So I need to get it hooked up to this so I can have stereo SID support, play around with some of those files. And not to mention, this is kind of silly with this wire hanging out here. So I need to wire this up to be this RCA jack right here. Right now, this is just composite video, so it's just convenient for me to connect up to. But the fact that I have this hooked up with the Lumicode now, it's just a lot easier for me to use the RGB HDMI, which I always have sitting here on my desk ready to go. That way I can get that crystal clear video image. Yeah, anyways, okay. What we haven't looked at is what's this stuff here? Here we go. Let's see what this is. The end of 2062, at what age will you be? Like from this, I can't quite tell what this is. We're dealing with some gals here. We have 3 gals. How old will I be at the age of 2062? And what's this? Is this the same thing? At the end of 2105, what age will you be? Well, I absolutely will not be alive anymore. I was born in 1975, which means at this point I'll be deceased. And at this point, I don't know if I'll be around anymore. Well, living to that age is obviously a possibility for some people. I'm a type 1 diabetic and I've been this way for a long time. It's very hard on your body and it causes cumulative damage. So it's very unlikely that I will live to be, you know, in my 90s, for instance, or I doubt even into my late 80s. I'll probably start to have some serious health complications before then, even though I try my best to stay healthy, keep my blood sugar under control. You know, I go to the doctor a lot to check out everything that's wrong with me. Obviously, I still have a bit of a cold here. You can hear it in my voice when I laugh. I sound like a smoker. But that's not normal, and hopefully I'll get rid of this. So, and you know, speaking of that, I'm just gonna check my blood sugar real quick, and after I've had a few of these candies and stuff, and just give myself a little extra insulin here, just to bring my blood sugar down. What about this little reward box here? Will this help explain what these gals are used for? I'm sure when I publish this video, Johan will watch, or I can just reach out to Johan on Patreon and we'll explain what I've missed here with these. Or maybe people watching will understand what these are here. Oh, wait a second. Is this one of those things so you can read gals and pals on an EPROM programmer? I think that's what this is. Yeah, look, PAL 16 LB or LA to 27C020 EPROM adapter. Right. Okay, so there are 2 types of PALs or gals, well, PALs or programmed gals. There are the L versions and the R versions. If it's an L version, it's just a logic. That means that all the various inputs into the IC just translate to output. So you can just run through every possible combination of input and then read the outputs. And theoretically, I guess that translates to the same thing as one of these EPROMs here, 27C020, and maybe there's a way to recreate those equations that do those logic equations that could make you allow you to make a new one of these. Now there's another type of PAL, and it's like a 16R8. Those ones have state tables and are more complex inside. So you can't just use something as simple as one of these things to read those out. But half the time, they're just the L versions, and then you can. Now, there are 2 versions of these, right? There's the 16 V8s, and there's a 20 one as well, which has more pins. And this little adapter here can only work with the 16 ones. So I think what we need to do is break out the EPROM programmer here, and we need to test this thing out. Okay, so the notch is there. That goes to here. So we'll get this into there like so. We'll get this thing connected up here. So there it is. And I guess what I need to do now is try to read these into the EPROM programmer. Maybe there's some secret code we can read out of these. So let's just try the first one here. In fact, I'm gonna put little dots on these so I can figure out the order. So 2 dots here, 3 dots there. Not sure if this is like some kind of riddle here that Johan has created. Okay, so let's just try 27C020. We'll turn off check ID. Theoretically, we can read this. No. That was not happy. Pin detect error. I don't need anything special here. Do I have this in upside down? Let's just double check. Let's try it without the chip installed. You know, I should have looked. And I can see the notch here. This is on the pins that go into the programmer is right here. And then the notch on the gal or PAL is also right there. So we put that back down again and we try reading this. I might need to turn off pin detect. So maybe what we should go do is look at the GitHub repo for this particular project. All right, here's the GitHub repo. It's from Johnny H64. Work started on this to create an ATX 286 motherboard based on the IBM 5170. Thread creator looked for help on how to retrieve the PAL equations from U87 and 130 on the IBM 5170 motherboard. While I tried to help, he figured the equations out with other tooling from technojunk.org, but I found the topic interesting, so I kept researching. Reverse engineering PALs has likely been done as early as 1980s, when plenty of companies cloned the PCAT. Probably this has not been publicly documented. The earliest description of the idea I could find was a schematic from 2007 with the title PLD Analysis Board, developed by Charles M. I'm trying to avoid publishing full names, hence M. But the site's no longer available, so a small subset of information and schematics can be found here at this URL. It looks like we have some more info just about the kind of iterations of this type of work. All right, so and as far as restrictions go, it only supports the PAL 16L8 for reading. And that's interesting, actually, a little bit of a problem there, because sometimes these GAL chips have code you need to get off of them, but they're also protected, so you can't just read them with the EPROM programmer. This programmer supports reading and writing GALs, like these lattice ones. Problem is, if they're protected, it can't do that. Anyhow, it looks like this is a one-step solution that turns a PAL 16L8 into the form of a GAL 16V8. It consists of a KiCad project, which obviously is a little PCB we have here, a Python script, pete.py, to convert the PAL dump into a truth table and GAL equations, and a Python script. You know, I just got a phone call and was finishing up the phone call thinking, looking at this stuff on the bench here, thinking, maybe I should have done the actual calculations here, and I was supposed to do something here to get my reward, and I completely blew the game and just like opened the reward without actually doing anything here. So going back to this puzzle here, I'll be 130 here at the end of, or in 2105. And for this one here in 2062, if I were still alive, I'd be 90 years old. Now, what does that mean when it comes to my reward, which I already blew and opened? I don't know. I don't know at all. What I am curious about, maybe I could just read these chips directly in here, because these are just regular GALs, and we'll just pick the 16V8. Is this an A variant? Where's my little magnifiers? This is the B variant, actually. I don't know if that really matters necessarily, but perhaps it does. So we just read this, and it did read it. We see stuff. What does that mean? I don't know. I really don't know. Makes me wonder, is the contents of these chips different? So we'll put the second one in here. And I think we can do a verify. Yes, looks like it has the same contents on here. Let's read this. Yeah, it looks the same. I have a feeling if I could have read all of Johan's letter, then probably I could understand this a little better. And I have a feeling that people watching this are probably like screaming at their screen on what this means. And I'm just being a dunce here, and I just do not understand. So I'm editing the video and I'm thinking about this riddle here, and I kind of came to the realization that clearly I think what Johan has gone ahead and sent me are the GAL replacements for the PALs that were on the IBM PC 5170. Now, what I don't know is obviously the AT being highlighted, that's the 5170, and the U is likely the location of the IC on the motherboard. Now, what I don't know is it U130 and U90, or is it something else? I don't know if Johan knows the year I was born in. So I'm kind of thinking that probably this has more to do with the age of the IBM PC AT, which came out in 1984 here in North America. So for 2105 minus 1984, so that would make it U121. And I mean, if there's a possibility that has to do with my age, because it says will you be? So, and this other one here either is U90 or 2062 minus 1984, so U78. Look at my scratchy writing. I'm using a mouse here. And let's take a look at minus 0 degrees. They should have a high-res photo here of the first one here. So, oh, this is really not high-res. So there are multiple revisions of this motherboard. I don't know if the component markings have changed on this. Is this one of the PALs right here? Oh, it's just completely unreadable. Let's look at the only other photo on here and see if that is somehow better quality. Oh yeah, that is not better quality. How about RetroWeb having a better quality photo? Okay, yes, that is far, far better. Well, if we look at this one here, we either have U90 or U78. Well, U76 is the math coprocessor here. I don't see anything that could be U78 here. And then there's U90, the only other possibility. That's clearly not one of the PALs. I don't actually see off the top of my head any PALs on here, but I have only looked for a moment, and it could well be that they're on the other revision, or I've just sort of missed it here. Okay, hold on. That's got to be one of them right here at U87, which neither of my calculations here seem to match. But I think this could easily be due to the fact that we're looking at this revision, which is the Type 1 motherboard. It has this double stacked DRAM. In fact, I have two 5170 motherboards, and they both are this type here. There's the other one right there. U131. I think that's it. Or you know what? I don't think it's 131. I think it's U130, which actually matches this calculation here based on my age. So that would make U90 the 2062, which, like I said, I'm quite sure that this is the other PAL chip on the board, and that does not match. So let's go to the RetroWeb and we'll look up. There's no photo of the Type 2 or 3. All right, well, back to the riddle. I'm pretty sure that these chips are the U130, which is the one up on the top edge of the board, and that this one is are the GAL replacements for the other PAL that's on the 5170 motherboard. That was a fun little riddle, and I have to admit, while I was filming the video, it did not come to mind, but think about when I'm doing a video, I'm a one-man show, so I have to worry about the audio levels and the camera angles and the focus of everything, and that my computer's still recording and all that, and then of course talking and narrating and doing a whole lot of stuff. There's a lot of mental load for me, so there's not a whole lot of riddle solving skill, brain power available while I'm doing a video. Anyhow, we saw on the GitHub repo that we can't just read these in this little adapter. We have to read PAL 16 L8s. Well, I happen to have this random board sitting here, and this has some on here. I don't know what this thing does. We figured out with the help of some of my patrons that this is like a multi-IO thing. This is like a microcontroller, and this is like a 8-port or 16-port serial, like as in RS-232 board. And then this has this kind of like minimal version of DOS that boots. So you stick this into a computer, and it starts to boot, and then it tries to access like a CD-ROM drive. It loads a CD-ROM driver, IDE driver, and then it's supposed to do more from there, but I don't have that. And on the back here, we have a 15-pin, like a DB15, 2 RCA jacks, plus a little pin header there. And originally, it had the PC speaker hooked up here. So who knows what this does, but it does have some PALs. So what we can do is we can try to read those on the little board here. So we'll just get this one out here. I'm sure this is something to do with like chip select or whatever. Put this in the correct way around, like so. Pop that down. Back in the software here, we'll do a 27020. We'll pick that, turn off check ID, and we'll try reading here. Same thing with these pin detects. Well, let's take a look back at the repo here. So we got to generate the dump. So stick it in the adapter and then into your chip programmer. Do not put the PAL in your programmer directly. This will not work. Yes, we know that. Instruct the programmer to read a 270C020 and save the data file into a file. The generated file is 256K. If you own one of the MiniPro, blah, 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 and have excellent command line. Okay, we know that. I found this dump does not work reliably due to timing issues. Please make sure to perform the dump multiple times to compare the files. Generate the equations, fix up the equation, generate the JEDs, and then you can program the new GAL chip, like the lattice ones. These are the ones that were included by Johan here, directly with the programmer. And we have some examples here. So like reading right out of the one on the IBM 5170, and so on and so forth. But I guess the question is why do we have this issue here? Bad pin. Now what I can do is I can just turn off the pin detect, and let's just try that, I guess. See what happens. Okay, we see things. So that's a start. Now what we can do is we can read this multiple times by hitting the verify option here. And what this will do is we'll compare the buffer, which of course was the first read, by subsequent reads. So you don't have to read it multiple times to compare. All you have to do is this. So if we found any difference in the readings, it would definitely give us an error here. So this is cool. This adapter is very helpful. You could build one of these by hand, obviously. Just saw the schematics were in the GitHub repo, but this is a really simple and easy way to do it here. And even if the PAL chip is protected, or the GAL, it should read the GAL chips just the same as well. I don't see why it wouldn't work with the GAL 16V8. That is protected if it's just logic equations that are added into it. Okay, so I've read this several times and it's definitely the same every time. So let's save this. I'll save this as test.bin. I grabbed the code from the repo and we have these Python scripts here. Looks like I need this SMMC package here. Okay, it did finish installing. Looks like I have an old version of pip, but that's fine. All right, and to convert the dump I made to equations, we use this here. So it's test.bin. Maybe if I was in the correct directory. Okay, there we go. Now we're in the right place. Let's see how this goes. This machine I'm running this on is a Ryzen 5600. So it's not the slowest computer in the world. It's obviously not the latest and greatest either. So what did this do? So adapting the file name, this will generate a file called palpetequations.pld, adapted from your file name. Okay. So test Pete equations PLD. Are these actual equations? Oh, they are. Right. So GAL 16V8, and that's all pretty simple. Now the card doesn't really work, this card. It's not like I can put the chip in here and test. But what we have is other PALs on here. So what we need to do is dump those as well. And I'm going to do the same process here and just see if we get a different output here. But these are the equations here. So like, it's not pin 13 is, this and this and this and not that and not that. So you have those logical equations there result in the output of pin 13, I guess, and stuff like that. So let's just go through the same process again here. So this is another chip off the board. I guess I should put this thing back in here because someone might recognize this board and be like, hey, I know what that is. So I should at least keep the chips in their respective locations. Okay, here we go again. Let's try reading the next chip here. First of all, if we do a compare, so we'll do a verify that what's in the buffer here is the last chip. And yep, right away we have a difference. So we just abort out of that. We'll read this. And we have some stuff, and we do a few verify passes, just like we did last time. Okay. Yep, seems fine. I'll just do 2. We'll do save, and we're going to save the next one. It actually is u7.bin. That's the location of this chip on the board. So this is u7.bin, and there goes with its thinking. And the other chip that we just made was u13. So we can just fix that here, u13. All right, it's relatively quick. And the file we just made is this one here. So let's take a look at that with Notepad+. U7. Oh, right. Completely more complicated and different equations. Right. Okay, this is freaking awesome. I notice here it made a text file as well. Yeah, I'm kind of assuming that these are like non-simplified or non-factored equations. And back on the repro, it says a GAL only supports 7 products per output value and only 1 product per output enable. For complex PALs, where one output value depends on another output value, pi.pi might not be able to find equations within these limits. In this case, you need to think of how to optimize further to fix up the equations manually. Well, do I really fully understand what that means? I do not. So let's just quickly take a look at these PLD files really quick and see if anything violates the rules. So it said 7 products per output variable. So I'm assuming if we have like 7 things here, that would be, or more than 7, that would be too many. So that's obviously 5, 5. So we're fine on those ones. That's U13. But on this one, I don't quite get this. Like, what are these hashtags? So is this one too complicated, for instance? Like that couldn't work because of the GAL and it works on a PAL? And then this one here, pin 15, 1, 2, 3, 4, 5, 6, 7. That has 7. Is that the limit? I don't know. But I guess the question is what are these ones here? Is this violating the limit? I don't know. Anyways, we can create the GED files, which are what you need to actually create a replacement for the PAL chip. And that's with this simple galasm.py. So U13 here, there's the one that was more simple, I think doesn't violate any rules. It worked. And let's try the U7 here. I mean, it didn't give an error. So I don't know if that doesn't really tell us a whole lot. All right, so in with one of the gal chips here, and we're gonna pick a lattice, 16V8B as in Baker. And remember, there's some code on these already, or at least that's what reads back. But in the directory here, we actually have the two GED files that I just created. So U13 is that one there, which, you know, stuff, right? And we hit program, and theoretically, I probably should have turned off encrypt. Let's try verifying the chip. It failed, and I'm pretty sure that's because the encryption is turned on. So if we program it again with the encryption option turned off, now I should just be able to hit the verify command, theoretically, and it should verify. Okay, let's see what happens now, and we do verify. And there we go, it actually verifies. Yeah, it's kind of interesting. So look at this pattern right here. Let's turn that back on and hit program. I'm curious what it looks like when you read back a chip that's been encrypted. Okay, so we know it's programmed. Now let's try reading it again. And okay, look, it's all just mostly ones and a little bit of zeros at the end. All right, so theoretically, and I should have tested it with something that's, well, I know how to use versus this board, I can recreate 16 L8s, not V8s, L8s, and not the R8s, but the L8s. That is freaking awesome. So the question I have for my viewers watching now, or of course Johan if you're watching, is what did it mean about re-simplifying the equations and only supports 7 whatever components or whatever the exact terminology was? And was that U7 file that I created using this, was that not going to work because it seemed to have far more than just 7 components there making up one of those outputs? I know very little about programming pals and gals. I've done a little bit of work actually creating the equations that could be programmed into gal chips. And I actually have this program I use that I found ages ago called this one here. It's called Logic Friday, that allows you to manipulate or create these formulas based on truth tables. So if you have a set of inputs and a set of outputs, you define them here with this program, which comes from 2012. Stephen Rickman wrote this. And of course, Windows with its backwards compatibility, this still works perfectly on Windows 10, and I'm presuming Windows 11. But the way this would work is you would say new truth table, and you define the number of inputs and the number of outputs. So let's say we have 8 outputs and we have 4 inputs. And when you do this, it creates this truth table here. And essentially based on all the possible input conditions where you have all 16 of them here, you define where all the outputs are. So I'm just gonna like click around here and create some ones randomly around here. And I think I hit enter here. And what this does is these are the equations here. So P0 through 7 are the outputs, and then these are the inputs. So it's A and not B and not C, and D equals the output of P3. And you can do all sorts of stuff with this to minimize the equations, so you can like factor them and stuff like that. So I think what might be possible with this program is I'm wondering if we can open these GED files here. It doesn't really support it. So I'd have to like translate those files into the format that this thing supports. And then you could load these formulas right in here, and then you could help you manipulate them and minimize them and optimize them and do that kind of stuff. The other thing this can do, which is really freaking awesome, is you can create a gate diagram. And I haven't really used this in a while, but this absolutely does work where you can connect these things together. And I kind of don't remember how to use this right now. So there are 4 inputs going into that, plus another input that goes into here. And then I connected the output of this gate over to here, and let's create an output right here. So there's an output. So we have 2 outputs and we have 5 inputs. So if we hit submit now, what this does is it creates the truth table automatically based on the way these logic gates work, and then it creates the equation that would then be factored and converted into a table that we could then turn into a gal chip. So it turned this long set of equations here into this. Remember, there are 2 outputs on here, and then this is the exact equation that reproduces this set of logic gates inside of a gal chip. And while this thing is missing certain types of TTL chips, because you saw when I was entering the gates there, it had like a mux and various different gates and stuff like that, you can do quite a lot of powerful things here to then end up with the factored equations that could then be exported and converted into a gal chip. And we can do some minimizations here. So we can say slow exact minimizations and smallest number of product terms. Let's try this. And there we go. Now this looks way simpler. And remember with that limit in the gal chip with like 7 or whatever it is, I think we were exceeding that before, but I don't think we are any longer. And sure enough, this minimized equation here does match exactly what we get here with this logic diagram. That's why I absolutely love this program. And I don't know if there's like better tools out there to do this stuff now, but I found this thing forever ago. I don't even know where to get it. But as I mentioned, if you want to find this yourself, it's called Logic Friday, and I'm running version 1.14. And going back to the PLD file, the way Logic Friday creates its equations, now obviously these ones are like the same as having an exclamation for the not, right? But what I don't remember is like the plus, is that the same as the and? And I'm assuming these are ors. So let's see how this works. So I assume those are ands. What about ors? Where are ors represented in here? Are there any ors? I don't see any ors in here. And what I don't remember is when there's nothing between the letters, is that an and or an or? I'm thinking it's probably the ors, and these are ands. Anyways, you have to do some conversion here to convert to the format that this uses. And then you could take the output of that Logic Friday and then get a GED file from it. Now there are tools made by Lattice that I have on my computer somewhere that do this work for you as well. And I recall having to manipulate the output of Logic Friday. The equations, again, didn't quite match what those Lattice tools were expecting. But now I have this Python script to do the same thing. I'll just use this instead. Why bother using those Lattice tools? This thing will run on anything, including modern computers. And that Lattice stuff is like ancient software that's just not really supported anymore. I don't think it is, at least. I am pretty sure there are people watching who know way more about this stuff than I do, especially like how to convert these equations from Logic Friday into the format that the Python scripts need. And of course, vice versa, because it would be possible for me to take the output of these PLD files and convert them into the format that Logic Friday uses, and then I can use that to help minimize and recreate the formulas a little bit. I think I could, at least. Again, we're all a little bit beyond my expertise, but it's absolutely something I would definitely love to learn about, because plenty of times I encounter boards like this and I dump the ROMs, but then we have these PAL chips on here that I don't dump, because until literally right now, I did not have an easy way to do that. So thank you very much, Johan, for sending in the candy and these 2 SIDKICK boards, which I'll have my friend Sylvester build up for me. And then, of course, this PAL dumper. Freaking awesome. It was just the other day someone was telling me about, I think, this project actually. So I had one literally sitting here, my big box of mail call items, the whole time. I still have a whole bunch of stuff to go through, but I think I'm losing my voice a little bit just because I'm still slightly sick. So that's going to be it for this mail call episode. Thank you very much to Lorenzo for the candy from Italy, and then from Johan for all this cool stuff. And thank you to everyone else who sent stuff into mail call. If you have sent stuff in, you haven't seen it yet, I do apologize. It's just, there's probably 40 more things in this box here on the floor, and most of them are small packages like this, which means that it's going to take me quite a while to get through all of them. So if you enjoyed this video, thumbs up, definitely comment down below, especially if you have experience with these awesome SIDKICKs and using this PAL dumper. Let me know how I can put this to good use in trying to back up some of the chips that are on these boards. I definitely run across old motherboards sometimes that have normal PALs on them, PAL 16 L8s, that I would be able to dump. And that's great, because if you end up with one of those motherboards and someone stripped the chips off there, and one of the chips that was missing was one of these PALs, then I should be able to convert the into equations for you, and then you could make a new one with the gal just using a simple programmer like this. So yeah, comment down below to give me tips and pointers. I would greatly appreciate that. I'll try to put the links to all this stuff down in the description below. And a huge thanks to my supporters. Names will go up the side of the screen over here. They make it possible to do this full time. Links down below if you want to become a supporter. And I think that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.